For starters, parallel lines are lines that will never meet. So if you look at this line and that line, they have the same distance from each other along all points, and so they are running, and so they'll never meet. However, when we look at it in terms of vectors, we are looking at two lines, but one is shorter than the other. If you're to look at this line, it is probably half this line. In other words, if this is line A, this is twice. The length of this line is twice that. So it means this would mean that vector A is equal to halfway vector B. In other words, this one is, I would have to draw A one time. This is vector A, and then I draw another vector A to get B. In other words, if I can also be saying that B, vector B, is twice two vectors of A. For me to get the length of vector B, I have to combine two vectors of A. This is the diagrammatic representation of what I'm trying to talk about here. What I'm trying to show you here is that as far as vectors are concerned, for me to be able to prove that these two lines are parallel, it would mean that I'll have to express one of the vectors as a scalar product of another. This is a scalar product of this vector, and this is a scalar product of this vector. In other words, if I'm able to represent this vector as a scalar product of another, then it means those two vectors are parallel. For example, here, in the other instance, we can see that here A is moving in one direction and B is moving in the other direction. It's still the same analogy like we used here. This would mean that, for example, if we are to get B, vector B is equal to 2 of these, because this one is twice as long. So 2 of these, I'm just using an example. So if for me to get vector B, I'll have to get this vector A and multiply it by 2 to get B. So that's why I'm saying vector B would be twice of A. However, remember, when we are dealing with vectors, we are sensitive to the direction. So because this is moving in that direction and this is in the opposite direction, it means that this would have a negative right there. Here, both are positive because they are both moving in the same direction. Here, one of them is, the directions are opposing, so that is why the negative is at that point. Or if we are given any two vectors and we are told to prove that they are parallel to each other, we just need to express one vector as a scalar multiple of the other. If we can express one vector as a scalar multiple of the other, then we can prove that they are parallel. Let's do some examples to illustrate what I'm talking about. For example, here we are being asked to show that the following vectors are parallel. We have vector AB, we have CD, and these are the vectors. So I'll do this on a different sheet of paper. We have vector AB as 4, 6. Then I also have vector CD. It is -8, -12. And we are being required to show that these two vectors are parallel. So for us to show that these two vectors are parallel, we say that we need to express one of the vectors. Let's say vector AB. I'm supposed to express it as a scalar multiple of the other. Let me call that KCD. So what I'm going to do here is I'm going to put A, B, find the value of K, and well, let's get to the working. AB is 4,46, so I'll say 4, 6 is going to be equal to the scalar K. We are supposed to look for this value of K into CD. CD is -8, 12. -8, 12. So what I'm going to do here is I'm going to say 4, 6 is going to be equal to K -8, which is -8K, then 12 times K, which is 12K. So I'm going to find the value of K both up and down. So upwards, it is 4 is equal to -8K, and this side, and then if we divide both sides by -8 here, by -8 here, this goes with that. We end up with our value of K as by 4 once, by 4 negative 2. So our value of k here is negative a half. Likewise, below here, it is 6 is equal to 12k. Or this 12 has a negative, for this was negative 12, so this is negative, that is negative, this is also negative. So divide both sides by negative 12, divide both sides by negative 12, this goes with that. You remain with my value of k as 1 over 2 a half. So you realize that the value of k here is the value of k here. They are the same. So because they are the same, it would mean that this now has become, it has now become this. It means that it is AB is equal to our value of k, which is negative a half. So if it's negative a half, CD. So now that we have got a scalar which is connecting these two, so we shall conclude and say that since we conclude that like that, let's try another example. Let me leave Roman 2, you will try it out. Let me do Roman 3. Same stuff. Roman 3, we have x, y, and zm. Show that these two are parallel. This is how we do it. So we are supposed to show xy is equal to 4, negative 8, and zm is equal to 3, negative 6. We are supposed to show that those two are parallel. How do you go about that? To show that those two vectors are parallel, it is supposed to be xy, this one, is supposed to be equal to a multiple of this and the scalar. So in other words, we get our scalar k times zm. Our job is to find the value of k. If you're able to get the same value of k on top and bottom, then we have proven that these two are indeed parallel. So in this case, it's going to become 4, negative 8 is going to be k times zm. Z is 3, negative 6. Zm is that. So this is going to become 4, negative 8 is going to be equal to k times 3, that is 3k. This times that is negative 6k. So we shall go ahead and find the value of k. So we shall equate this. We shall say 4 is equal to 3k. Divide both sides by 3. We end up with k as 4 over 3. Then likewise here, we have at the bottom, we have negative 8 is equal to negative 6k. So here, negative 8 is equal to negative 6k. Divide both sides by negative 6. This goes with that. By 2, 4 by 2, 3. You end up with a value of k as 4 over 3. So you realize that the value of k here is 4 over 3. The value of k here is also 4 over 3. So since the values of k are the same, it means that we have a uniform value of k here. Now, if these values of k are not the same, it would mean that these two vectors are not parallel, and so would conclude that they are not parallel. But since we get the same value of k on both sides, it would mean that this condition is perfectly met. So it would conclude and say that since is equal to our value of k, our value of k, we've got 4 over 3 zm, then so that's how we would conclude that. So it is as simple as that. That is how we prove that vectors are parallel. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.